Welcome to the Deep Dive, where we take a stack of sources and extract the most important insights for you. Today, we're doing a deep dive into the fascinating and rapidly evolving world of React development. Specifically, we're looking at the design patterns and best practices for 2025. Our journey today is guided by a really insightful article by Hassan Jurdi, React Design Patterns and Best Practices for 2025. It was actually last updated just a few weeks ago, June 16th, 2025. This deep dive is basically designed to give you a shortcut, to being truly well-informed about building robust and maintainable React applications right now.
Indeed. And React has undergone quite a remarkable transformation since it first came out back in 2013. It's really evolved from just a UI library into, well, a truly comprehensive ecosystem. With React 19's stable release late last year and just the continued maturation of the whole development landscape, we're seeing powerful new features really streamlining how we build things. So our mission today is to unpack these critical areas: modern component patterns, the latest in state management, the absolute necessity of TypeScript, those groundbreaking new React 19 features, and of course the frameworks and component libraries shaping the future.
Okay, so let's kick things off with what feels like a really fundamental shift we've seen in React, that move towards a more functional programming paradigm. What's the real story behind function components becoming, well, the undisputed champions, replacing class components for almost everything you'd build today?
Yeah, what's truly fascinating there is how functional components just inherently emphasize simplicity and composability. They're kind of like little self-contained machines, you know? You give them inputs, they give you outputs, makes them incredibly straightforward to understand and to test. This design also integrates seamlessly with React's hooks system for managing state and handling lifecycle events. Think of, say, a user profile component. With hooks like useState and useEffect, it can effortlessly fetch and display user data without all the verbosity or complexities that class components often brought in.
That makes perfect sense. And speaking of hooks, the article really hypes up custom hooks, calls them one of the most powerful patterns out there for modern React. From your perspective, what exactly makes them such a game changer? How do they practically simplify building complex apps?
Oh, custom hooks are, they're genuinely a developer superpower. They allow you to extract complex, stateful logic into reusable functions that instantly cleans up your components and promotes incredible code reuse. I remember before custom hooks, right? I'd often find myself copying and pasting the same, like, form validation or input handling logic across maybe 5 different components. It was just a nightmare to update. Now, consider something like a useForm input example. It manages all the state and behavior for an input field. Then, components like a login form can simply use this hook. They instantly get consistent input logic. It makes the login form itself much more focused on just rendering the UI, and it simplifies testing hugely. It's really about writing logic once and using it wherever it makes sense.
Okay, so we've optimized components for clarity, reusability. Got it. But what about the data that flows between them or needs to be shared across the entire application? That's state management. The Context API has definitely stepped up its game, lessening the need for external libraries. But, in the past, developers sometimes hit performance snags with it, especially for data changing really frequently. Has React 19 truly addressed those concerns, or are there still cases where maybe an external library might be a better fit?
That's a great question, actually, and it speaks to a common concern people had. React 19 has indeed made the Context API more powerful, particularly with the introduction of the use function for accessing context values. The themed button example in the article showcases this brilliantly. The new use API lets your components grab context values like your app's theme, even if that component is only rendered conditionally, which means a less boilerplate, cleaner code, and more flexibility in how you design those dynamic parts of your UI. So for you, the developer, this means the Context API is now incredibly well suited for managing those broad application-wide concerns. Think about things like user authentication status, the global theme, localization settings, maybe feature flags. For these kinds of things, it provides a performant built-in solution. Now, for highly complex global state that updates extremely frequently across many, many deeply nested components, well, you might still find specialized external libraries like ZooStand or Jotai offering even more fine-grained performance tweaks. But honestly, for the vast majority of applications, Context API is now more than sufficient and often the preferred choice just for its simplicity.
Right, it sounds like a significant leap forward then, making state management more native, less reliant on third-party stuff. Okay, shifting gears a bit to something that's become almost non-negotiable in many new projects. TypeScript. It's integrated so deeply now. From your perspective, how does TypeScript fundamentally change a developer's day-to-day life? Does it really prevent those headaches?
Oh, absolutely. TypeScript isn't just about adding types, it's like having a coding copilot, seriously. It catches those sneaky mistakes before they even leave your keyboard, saves you from frustrating bugs down the line. It's about confidence, really. You get type safety, meaning errors are caught at compile time, not when your user hits some broken button in production. Plus, your IDE support just dramatically improves better auto-completion, refactoring, instant feedback right there. And because those type annotations serve as clear documentation, your code practically writes its own instruction manual. Makes it a joy for anyone else or, your future self to understand and contribute to.
That real-time feedback and documentation sound incredibly valuable. Yeah. The article also dives into specific ways TypeScript elevates React development. Can you highlight how it practically enables, say, type-safe components and hooks? How does it simplify what we actually build?
Certainly. So for components, TypeScript lets you define strongly typed prop interfaces. For a user card component, for example, you'd define user card props to explicitly say, okay, this component expects a user object with a name string and an age number. If you forget a prop or pass the wrong type, TypeScript instantly tells you right there, prevents runtime errors. And for hooks, it provides type safety for your state and effects. Take the use local storage custom hook example from the article. It uses generics, letting you specify the type of data you're storing, like use local storage string username. This ensures type-safe access and updates, providing consistent, error-free usage across any component that needs to interact with local storage. It's all about consistency and preventing those common mistakes.
And what about generic components? That sounds like it gives components some serious superpowers.
They truly do, yeah. TypeScript's generics enable the creation of highly reusable components that maintain type safety, no matter what data you throw at them. Imagine a selectee component, just a standard drop-down menu. With generics, this single component can adapt to any data type, whether it's a list of users, products, categories, whatever. And it preserves strict typing for props like what text to display or what key to use for each option. This offers incredible flexibility and reliability, lets you build truly versatile UI elements that are safe by design.
Okay, so we've covered the foundation, functional components, TypeScript, the evolution of state management. Makes sense. But now let's talk about the shiny new toys from React 19. It introduced several new hooks, use action state, use form status, useOptimistic, and that new use API we mentioned. Which of these particularly stands out for creating a noticeably smoother user experience, tackling that annoying lag we sometimes see?
Right. Well, for a genuinely smoother user experience, useOptimistic is the standout here, I think. Imagine sending a message in a chat app. Instead of waiting for a spinner, you instantly see your message appear in the chat, maybe marked as sending, right? That's exactly what useOptimistic gives you. It allows the UI to immediately display changes before a network request even completes. Creates a much faster, more fluid feel. The message list example in the article perfectly illustrates this. It makes your app feel incredibly responsive by immediately updating the UI with what you expect to happen, even before the server confirms it.
And then there are React server components. This feels like a really significant paradigm shift. But for developers, doesn't it add a new layer of complexity? Especially when you're trying to figure out, what goes where, or the bugging interactions between server and client logic.
It absolutely is a significant shift, yeah. And you hit on a valid point about the initial learning curve. It takes a bit to get your head around. Think of it maybe this way. Server components are like the preparation kitchen for your web app. They do all the heavy lifting fetching data directly from databases, processing complex logic before anything even reaches the user's browser. This drastically reduces the JavaScript bundle sizes sent to the client, making your app load incredibly fast. But they can't use client-side browser APIs or React state hooks simply because they don't even run in the browser. Then the client components are the interactive bits, the dining room of your application maybe. They get shipped to the browser. They handle user interaction like button clicks or form inputs, manage local component state. And importantly, they must be explicitly marked with that use client directive at the top of the file. The article's example of a product page as a server component and an add to cart button as a client component demonstrates this tag team really well. The server component handles fetching product details, rendering the static parts. Then the client component provides just the interactive add to cart button. It is about separating data fetching and initial rendering from client-side interactivity. It definitely adds a new mental model, you're right, but the performance benefits for the end users, they're undeniable and really worth exploring.
Okay, that analogy of the preparation kitchen and the dining room actually really helps clarify the distinction. Thanks. So with all these internal React advancements, the modern ecosystem wouldn't be complete without looking at the frameworks that build on top of React. The article highlights Next.js, Remix, and Vite. Rather than just a feature list, what are their unique philosophies or maybe their killer features that set them apart?
Yeah, they each definitely offer a distinct flavor for how you build. Next.js, for instance, is often seen as the comprehensive full stack solution. It gives you flexible rendering strategies like server-side rendering or static site generation. It has built-in API routes, features like automatic image optimization. It's kind of like the Swiss Army knife for complex production-grade applications. Remix, on the other hand, puts a huge emphasis on web fundamentals. Its routing system elegantly combines data loading and UI rendering. It really leans into browser native features for things like form submissions, and it has built-in optimistic UI patterns. It feels incredibly fast and resilient because it's built on a deep understanding of how the web should work, fundamentally. Then you have Vite. Now, while it can be used standalone, it really shines as a lightning fast development tool. Think of it as just a speed demon for your development workflow. By leveraging native ES modules, that's how modern browsers efficiently load JavaScript, it gives you near instantaneous server startup times. And hot module replacement so rapid it feels like your code updates the moment you type it. It's really about getting out of your way and letting you build with minimal friction during development.
Okay, so if frameworks are the overall structure, what about the aesthetics, the look and feel? Moving to styling, Tailwind CSS has become massively popular. What's the appeal of this utility-first approach? How does it fundamentally change a developer's styling workflow?
Tailwind CSS, yeah, it truly transforms how you think about styling. It really does. Instead of writing custom CSS classes in separate files and constantly switching context between your HTML or JSX and your CSS, Tailwind provides these low-level utility classes that you compose directly in your markup. You apply classes like flex, text, -lg, p4 right there on your elements. This pretty much eliminates the need for separate CSS files, significantly reduces that context switching headache, and allows developers to rapidly build visually consistent components. The product card example shows this well. It's really about speed, consistency, and having all your styling information right where you need it. And it's continued to evolve with better tooling and a bigger ecosystem, really cementing its place.
And for those bigger enterprise applications that might require more complex pre-built components, rather than building everything from utility classes, where do professional UI libraries fit in?
Ah, right. That's exactly where professional UI libraries like Progress Kenda React truly shine. Kenda React offers a really comprehensive suite of enterprise-grade UI components. I mean, everything from basic buttons to incredibly advanced charts and data grids. They focus on providing sophisticated behaviors, robust accessibility features, deep customization options, all right out of the box. The article notes Kenda React Free provides over 50 customizable components without any upfront cost, which is a fantastic starting point for many. And what's particularly interesting is the synergy. You can actually use Tailwind CSS in conjunction with Kenda React through its unstyled mode, so you get the best of both worlds. Pre-built functionality with flexible custom styling.
Wow, okay. We've covered a lot in this deep dive into React design patterns and best practices for 2025. From that fundamental shift to function components, the power of custom hooks, through the increasing importance of TypeScript as our coding co-pilot, to the groundbreaking new capabilities of React 19, those powerful frameworks with their distinct philosophies and flexible styling approaches like Tailwind.
Yeah, the overarching aim of all these advancements really is to help you build scalable, maintainable, and highly performant applications. Truly understanding these evolving patterns, the tools, the ecosystem updates, it can profoundly elevate your development process and ultimately the quality of the applications you create.
So what does this all mean for you listening? As you consider these advancements in React development, from the way server components handle data behind the scenes to how optimistic UI gives you that instant feedback, think about how these evolving patterns might fundamentally change the next generation of web applications you interact with every single day. The web is getting faster, smoother, more powerful, and now you know some of the key forces driving that evolution.